Hi, this is Divya, Assistant Professor Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the continuation of the previous video, which is called the overview of the semiconductor materials. Okay, here in this video, we are going to see about the difference between the copper and the silicon. Copper, as we all know that it is a conducting material. Okay, silicon is a conducting material. Copper, where the electron flow of electrons is more among the arbitrary circles, so where the electricity passes through and the copper gets conducted, it is a conducting material. Whereas in the silicon, where the energy band gap is there, the conductivity of the material is very low, so since it is called as a semiconductor material. This is the main difference between the copper and the silicon. Next, the main properties of semiconductor. What are the properties of the semiconductor? Semiconductors can conduct electricity under preferable conditions or circumstances. Okay, as I told you already, it can conduct electricity to a certain period of time by adding impurities or having some other materials which is added to it. It can act as a semiconductor. Okay, and for a specific period of time it can act as a semiconductor. After that it can move on as a conductor insulate. Semiconductors can conduct electricity under preferable conditions or circumstances. This unique property makes it an excellent material to conduct electricity in a controlled manner as required. As I told you already, the semiconductor material have a certain value where it conducts electricity to that point, and after that it will be acting as a insulator. Okay, as we can control it, the system can be controlled. Why? Because we can adjust, we can have a certain value to conduct electricity, and after that, once that value is reached, this will automatically will move on to the non-conducting position. Okay, unlike conductors, the charge carriers in semiconductor arises only because of external energy. Okay, since in conductors, the charge carriers, they present itself in the material. Here, the charge carriers can be infused by the external energy sources to the semiconductor devices. Okay, generally the resistivity of the semiconductor materials will be of 10 to the power minus 5 to 10 to the power plus 6 ohm per meter. 10 to the power minus 6 to 10 to the power 10 to the power minus 5 to 10 to the power plus 6. Conductivity will be of 10 to the power 5 plus 5 to 10 to the power minus 6 mho per meter. That is just reciprocal of the resistivity is called conductivity. Right. Next, the temperature coefficient of a resistance will always be of a negative flow. Okay, the current flow due to electrons and holes. The current flow in the semiconductor devices will be of due to the electrons and holes recombination in the system. Okay. Types of semiconductors. We have different types of main two types of semiconductors. One is intrinsic semiconductor and another one is extrinsic semiconductor. Intrinsic semiconductor is a pure form of semiconductor, whereas the extrinsic semiconductor is an impure form of semiconductor. A pure form of semiconductor, as I told you already in the previous video, which is germanium and silicon. Okay, whereas the impure form of semiconductor, we have another two categories, which is N-type and a P-type material. Okay, in N-type, which is called pentavalent impurities. These components are called pentavalent impurities, and in the P-type, which is called trivalent impurities. Okay, pentavalent impurities are called donor impurities. Okay, where the electrons will be larger than the holes. Okay, N-type material, which is called pentavalent impurities, where the electrons will be larger than the holes. Whereas in the P-type material, it is a trivalent impurity atoms, where the donor impurity will be, the holes will be higher than, larger than, or larger than the electrons. We can see the difference here. One is the type of semiconductor. We have main two types of semiconductor. One is intrinsic semiconductor and another one is an extrinsic semiconductor. In intrinsic semiconductor, which is the very pure form of a semiconductor, as I told you already, which is germanium and silicon. Here the electrons and hole recombination will be of equal, which is number of electrons is equal to number of holes, that is equal to number of intrinsic. Okay, whereas in the extrinsic semiconductor we have another two categories, N type and a P type material. N type is a pentavalent impurity and P type is a trivalent impurity. In both the N type and P type we are going to add impurities to it, but the impurities, what we are going to add is it based on how much the impurities we are going to add. That is, the number of electrons is greater than number of holes, whereas in which the electrons will be greater than holes in N type material, that is pentavalent material. In P type material, the holes will be greater than the electrons. This is the types of semiconductor materials. Thank you.